guys, my name is Destiny Castillo, and today we'll be finding the enthalpy of vaporization of a substance. The question we are working with today is from page 522, question number 8, under self-assessment. The question is as follows. The vapor pressure of a substance is measured over a range of temperatures. A plot of the natural log of the vapor pressure versus the inverse of the temperature in Kelvin produces a straight line with a slope of negative 3.46 times 10 to the third Kelvin. Find the enthalpy of vaporization of the substance. So this question is clearly asking us to find the enthalpy of vaporization of the substance. Now, how do we go about this? So first, because we are given a slope, that must mean that the Clausius-Clapeyron equation was used, because this equation is what creates a linear relationship between the natural log of vapor pressure and the inverse of temperature. This equation also tells us that slope will equal heat of vaporization over R, the gas constant. So we have a few things that we are then given from this equation from knowing this. First, we know the slope, which is negative 3.46 times 10 to the third Kelvin, which we got from the problem set. Then we also know the R is the gas constant, 8.314 joules over moles times Kelvin. Now, we have a few things to also remember as we're doing this problem. Our answer is going to be in the units kilojoules per mole, which is very important because the question answers it's a multiple choice question, and all the answers are in kilojoules per mole. We'll also keep in mind that our answer is going to have 3 sig figs, because when dealing with multiplication and division, we always use the lowest number of sig figs seen in the equation, and that is going to be 3. So now let's begin our equation. Our first step is going to be to rearrange this slope equation in that we are solving directly for the heat of vaporization. So what I'm going to do is I'm essentially going to cross multiply. So I'm going to do slope times R equals negative heat of vaporization. And now we are going to plug in what we have. So first we are going to plug in the slope, negative 3.46 times 10 to the third Kelvin, don't forget your units, times R, the gas constant, 8.314 joules over moles times Kelvin equals negative heat of vaporization. Now, this answer is going to give us 28,766.44, and our units are going to be joules per mole because the kelvins will cancel out, equals the negative 28,766.44 equals the negative heat of vaporization. And we're going to take out the negative 1. So then now positive 28,766.44 joules per mole equals heat of vaporization. Now we're not done yet because, as I said before, our answer is going to be in kilojoules per mole. So we know 1 joule per mole equals 0.001 kilojoules per mole. So now what we're going to do is we're going to use dimensional analysis to go from joules to kilojoules. So we'll have 20,766.44 joules per mole times 0.001 kilojoules per mole over 1 joule per mole. So now what's going to happen is the joule per mole is going to cancel out, and we are going to be left with the answer of 28.76644 kilojoules per mole. Then, as I said before, our final answer is going to have 3 sig figs. So we're going to have the heat vaporization equals 28.8. Since we have 3, we're going to round up the 7 to an 8 kilojoules per mole. And that is answer B from the multiple choice selection. So basically in this problem, we found the heat of vaporization using the slope, and then we used an equation that we know from the Clausius-Clapeyron equation, and we rearranged that to find directly for the enthalpy of vaporization. Thank you, and I hope that made sense. Bye.